Welcome. So in this lecture, we'll be discussing the system architecture of GSM. Basically, we'll be discussing the system architecture of GSM under three main headings. These are radio subsystem, network and switching subsystem, and operation subsystem. So we'll be discussing this topic under these headings. So first let us try to understand the architecture. This is the system architecture of GSM. Here there are many entities are there. Now let us try to have a brief understanding of this. So this all these things put together, whatever in this everything, all this put together is called as RSS, that is radio subsystem. And all these things put together, so all these components put together, all these forms the network and switching subsystem. And these all these databases put together, these form the OSS, operation subsystem. Okay. So in RSS, you can see there is something called as BSS. There is something called as BSS, which stands for base station subsystem. Base station subsystem. That is, every base station will have many radio cells. Every base station will have many radio cell, and each radio cell will have a BTS. Each radio cell will have a BTS, that is base transceiver station, which is the tower, which is nothing but the tower. Okay, base transceiver station, that is base transmitter and receiver. And the mobile stations will be connected with the BTS through an interface, and that interface is called as UM interface. And every BTS will be connected, all BTS will be connected to one BSC, one BSC, which stands for base station controller. It stands for base station controller. So like that, there will be several BSCs. Like that, there will be several BSCs, and each BSC will manage one base station subsystem. Okay. So and then all BSCs, all BSCs will be controlled by an MSC. All BSC will be controlled by an MSC, which is Mobile Service Switching Center, and there will be one MSC which is called as Gateway MSC, which will connect with the wired network like ISDN and PSTN. And there are some registers like VLR, HLR, which are called as home location register and visitor location registers. And then we use some databases like equipment identity register, authentication center, and operation and maintenance center. So this is a brief overview of the GSM architecture. Let us now discuss in detail about how this architecture works and what is the job of each of these particular components, whatever we have now discussed. So let us start with the radio subsystem. All radio specific entities. So this radio subsystem includes all radio specific entities. Okay. So radio subsystem, it includes all radio specific entities like mobile station and base station subsystem. Okay. So as we have already discussed, RSS and NSS, that is radio subsystem and network and switching subsystem, are connected through an interface, and that interface is called as A interface. And that interface is called as A interface. And they are in turn connected with the operational subsystem using an interface, and that interface is called as O interface. The A interface is typically based on circuit switched systems. is based on circuit switcher system, whereas the O interface uses the signaling systems. So now let us understand the various other subsystems within radio subsystem. So first let us see about the base station subsystem. So the base station subsystem, uh, so a GSM will have a GSM network will have many BSS. Yes, it will have many base station subsystem, and each base station subsystem will be controlled by a BSC, base station controller. The BSS performs typically all functions necessary to maintain the radio connection to one mobile device. It also performs tasks like coding, decoding of voice, data adoption to and from wireless networks. Apart from BSC, the BSS also contains several BTS. BSS also contains several BTS. BTS stands for base transceiver station. BTS stands for base transceiver station. BTS comprises all radio equipment. That is, it includes antenna, signal processing equipments, the amplifiers necessary for radio communication. All these things are part of BTS. A BTS will typically form a radio cell using sectorized antennas. Several cells, uh, it will form such several cells, and it will be connected. BTS will be connected to the mobile station through an interface, and that interface is called as UM interface. And it will be connected with the BSC. The BTS will be connected with the BSC through an interface, and that interface is called as ABS interface. Okay. So UEM interface contains all the mechanism necessary for wireless transmission like TDMA, FDMA, all these things it includes UM interface. Whereas ABS interface, it consists of 16 or 64 kilobits per second connection. A GSM cell can measure between some 100 meter and 35 kilometer depending on the environment. Okay. That is environment in the sense it includes buildings, open space, mountains, but also expected traffic. Okay. What is a GSM cell? Can cover up to, either it may cover up to only 100 meters or it can go up to 35 kilometers depending on the environment. If it is free space, there is no buildings, etc., max it can go up to 35 kilometers, right? And then we have base station controller, BSC. The base station controller, basically it manages the BTSs. Basically what it does in the sense, it manages all the BTS. It it reserves radio frequencies, and also it handles handover from one BTS to another. It also handles handover. So handover means when the signal becomes weak, the mobile station should be connected with some other base station. So that concept is called as handover. So it also performs handover. The handover task is also done by uh, BSC. Okay, handover from one BTS to another within the BSS, and it also performs paging for the MS. The BSC also multiplexes the radio channels onto the fixed network connection at the A interface. Okay. It multiplexes the radio channel onto the fixed network connection at the A interface. So these are the various subsystems of radio subsystem. Okay. Now let us try to understand what the mobile station contains. So typically the MS is mobile station. It includes all user equipment and softwares needed for communication with the GSM network. So typically it includes all user equipments and softwares needed for communication with the GSM network. Okay. So MS consists of, it also includes user independent hardware and softwares. It includes user independent hardware and software. Okay. So, and mobile device can be identified by using a special number, and this number is called as IMEI, International Mobile Equipment Identity. The mobile device can be identified with a unique number, and this number is called as IMEI, where IMEI stands for International Mobile Equipment Identity. So this is to identify the device. It is no way connected with the SIM. It is no way connected with the SIM card, whatever the mobile uses. Whereas a user can personalize a mobile device by using SIM cards. The user can personalize the mobile devices by using SIM cards. Okay. So SIM cards will be used. So SIM cards will be used. So SIM basically stands for subscriber identity module. SIM stands for subscriber identity module, and SIM basically is used for user specific mechanisms, for performing user specific mechanisms like charging, authentication. All these are based on SIM. These are not based on the device. Okay. Some of the device specific mechanisms are theft protections. So for theft protection, device specific mechanisms like IMEI, International Mobile Equipment Identity, will be used. Okay. So for user specific mechanism, SIMs will be used. For device specific mechanism, IMEI will be used. Without the SIM also, a mobile user will be able to make emergency calls. Without the SIM also, the mobile user will be able to make emergency calls. Okay. So normally SIM contains many identifiers and tables, and also it contains many numbers and the list of services it is subscribed to. These details are stored in the SIM. Okay, these details are stored in the SIM. So a SIM includes a number called as PIN, which stands for personal identity number. It stands for personal identity number. It also includes another number called PUK. It also includes another number called PUK, which is pin unblocking key. Which is pin unblocking key. And also it contains an authentication key KI. Also it contains an authentication key KI, and also it includes something called as IMSI, International Mobile Subscriber Identity. So this is nothing but the phone number. This is the mobile number through which we call other mobiles. So that number is called as IMSI. Okay. Whereas the device itself is identified by a number, and that number is called as IMEI, International Mobile Equipment Identity, that is used to identify the equipment. Whereas IMSI, International Mobile Subscriber Identity, that is used to identify the SIM card. Okay. So these are the various numbers that are associated with the SIM. So basically, PIN is used to unlock the mobile device. The PIN number is used to unlock the mobile device. If a user presses, if a user gives 3 times wrong pins, then the SIM will be locked. Typically, it may not be relevant for all what do you call it, all service providers. Typically, in few cases, if the user gives the pin wrongly for 3 times, it will lock the SIM. Okay, in such cases, PUK is needed to unlock the SIM. Okay, if the SIM get locked, then in that case, PUK, that is pin unblocking key, is required to unblock the SIM. The MS also stores dynamic information when it is logged onto GSM system. So this dynamic information includes cipher key, KC, and location information like TMSI, temporary mobile subscriber identity. So for example, if the mobile station is moving from one base station to another base station, then temporarily it will be identified with a number that will not be known to the users but for control aspect, it will be identified with another number, and that number is called as TMSI, temporary mobile subscriber identity. So these informations will also be stored in the SIM. Okay, and also it will include the location area identification, which is called as LAI. It also includes the location area identification, which is called as LAI. Okay. Typically, mobile stations for GSM have a transmit GSM 900. There are different versions of GSM. So if you take GSM 900, so it has a transmit power of up to 2 watts, up to 2 watts. Whereas GSM 1800, it has a transmit power of only up to 1 watt. Because 1 watt is enough for GSM 800, because here the cell sizes are smaller. In GSM 900, the cell sizes are bigger. So it needs 2 watts. Whereas in case of GSM 1800, because of smaller cell size, 1 watt power is enough. Apart from the telephone interfaces, mobile station can also offer other types of interface to the users. Okay, so uh, that is mobile station is not only used to make telephonic calls. Okay, it nowadays it has other uses, other usages also. So it will have a display, it will have loudspeakers, it will have microphones, and also it will have some programmable soft keys. Okay, so further interface uh, uh, may include like connecting to a computer modem or Bluetooth. Okay, so these are like mobile. Also, the mobile station contains different interfaces. As technology uh, improves, the various interface also uh, getting improvised. Okay, so mobile phones comprise many vendor specific functions, and some of the functions vary with vendors to vendors. Okay, so Samsung may offer some feature which Apple does not offer, and Apple may offer some feature which Samsung does not offer, and many other mobile phones are available. They may offer some features. Okay, right? So typical, there may be many vendor specific features such as cameras are available with all mobile phones nowadays. There may be some of the mobile phone may support fingerprint sensors, calendars, okay, address books, games, and internet browsers. And also it may see nowadays we have apps. Nowadays we have apps. Whatever the app you want, you can download and install. But in addition to the app, the mobile phone itself come with the basic software. So those basic softwares may vary with vendors to vendors. Of course, every vendor will provide a common set of basic softwares, but in addition, they also provide some softwares that will vary from one vendor to another vendor. Okay. So personal digital assistants with mobile phone functions are also available, which is nothing but the iPad kind of thing. Okay. Uh, so we should also know that the mobile station can be integrated into your car. So nowadays you might have seen there are cars mm, which has integrated some mobile oriented system into the car, especially for route management, so that is nothing but a mobile station is integrated into the car, and they are using location GPS services for traveling. Okay, or it can be used with a container for tracking the container. Okay, so you can use a mobile station within a container to track the container. So using GPS, it can be tracked. So that way, it can be used in what you call to track when you send some item from one place to another place. For that purpose, also mobile station can be used. Okay, so these are the various subsystems that are available under radio subsystem. Okay, so the radio subsystem includes base station subsystem, BSS, base transceiver station BTS, and base station controller BSC. Then we have discussed about the various features that are available in a mobile station. So the next subsystem that we will be discussing is network and switching subsystem. So this network and switching subsystem is the heart of GSM. This is the heart of GSM, Global System for Mobile Communication. The network and switching subsystem connects the wireless network with the standard public networks. So this is the one which connects the wireless network with the standard public networks, and it performs handovers between different BSS. It is also responsible for performing handover between different BSS. Okay. For performing handover between different BTS, radio subsystem is responsible. For performing handover between different BSS, network subsystem is responsible. It includes functions for worldwide localization. Worldwide localization means identifying the mobiles at different parts of the world. Okay, a user may be traveler, a person who is a Indian, who is having an Indian mobile, who may go to US, and then when you make a call to him, the mobile network should first identify where is locality. Okay, so identifying the mobile stations, the locality, that is called as localization. So that localization is done by network and switching subsystem. Localization is done by network and switching subsystem. Okay, and also it performs other tasks like charging. Okay, charging, accounting, roaming of users between different providers in different countries. Okay. So the mobile user may roam, he may move from one place to another place. Sometimes he may go to a place where his network is not available. So he may be have to connect with some other network for communication. So such features are also part of network and switching subsystem. Okay. So the network and switching subsystem contains many switches and databases. So what are they? That let us try to understand now. Okay. So one of the switches that is available in network and switching subsystem is mobile service switching center. Mobile service switching center. So basically, so mobile service switching center is is called as MSC. So MSCs are basically high performance digital ISDN switches. So these are basically high performance digital ISDN switches, integrated services. ISDN we have already discussed. It is integrated services digital network switches. Okay. They set up connections to other MSCs and to the BSCs. So basically this unit MSC is responsible to set up connection with other BSC and MSCs via an interface, and that interface is called as EI interface. Okay, and it form the fixed and form the fixed backbone network of GSM system. So this creates the backbone for the GSM system. Typically, an MSC may manage several BSCs in a given geographic area. An MSC may manage several BSCs in a given geographic area. Okay. There will be one MSC called as gateway MSC that has additional connection to other fixed networks such as PSTN and ISDN. There will be one special MSC called as gateway MSC that will have a connection to the fixed networks. Okay, so let me go back to the diagram. So you can see here we are discussing about MSC. So this is the special MSC which has connection to other networks like ISDN and PSN. So that is what we are discussing right now. Okay, so there will be a special MSC which will connect to the fixed networks like the fixed networks like PSTN or ISDN. Okay, using additional networking functions, an MSC can also connect to public data networks. Okay, using additional functions, an MSC can also connect to public data networks. Okay, an MSC handles all signaling needed for connection setup, connection release, and handover of connection to other MSCs. Okay, it is setting up the connection, connection release, handovering the connection from one MSC to another MSC. All these tasks were done by all these are done by MSC. Okay, the standard signaling system is used for this purpose. Okay, so standard signaling system is a concept that is used for this purpose. So the standard signaling system covers all aspects of controlling signal for digital networks. Okay. So it takes care of all aspects of controlling signals for digital networks. Some of the features of standard signaling systems are number portability, free phone toll, okay, collecting money from the toll gate, okay, call forwarding, three-way calling, okay, all these are some of the features of standard signaling system, okay. And MSC also performs all functions needed for supplementary services such as call forwarding, multi-party calls, reverse charging. All these tasks also done by MSC. Okay, so this is the brief description about MSC. And the next register, one of the register that is available in network and switching subsystem is HLR. So HLR stands for home location register. HLR stands for home location register. So this register is it stores all user relevant information. HLR stores all user relevant information. So, it comprises some static information and also it includes some dynamic information. So the static information it includes or MSISDN. MSISDN stands for Mobile Subscriber ISDN number. So this is one of the static information that is stored in HLR, home location register. Okay, and also it includes other subscribed services. What are the services the user has subscribed for? That details will also be stored in HLR, home location register. Okay, home location register is a register which is a part of networking and switching subsystem. So this subscribed services may include features like call forwarding, roaming restrictions, GPRS, okay, all these things. And the international mobile subscriber identity, that is the IMSI number, your actual mobile number, that is the SIM card number, that also will be stored in HLR. Okay. So these are the static information that HLR contains. So the static information the HLR contains includes MSISDN, the services the mobile user subscribed for like call forwarding, roaming, GPRS and IMSI number. And the dynamic information it includes or the current location area of the mobile user, which is LA, Okay, the mobile subscriber roaming number. If the user is roaming, he will have a different number. That number is called as MSRN, mobile subscriber roaming number. The current VLR, currently he is connected with which VLR. If the user is staying in his home location, then he will be in his VLR location, in his HLR location. But if he is traveling and if he is staying somewhere else, then what is his current VLR? And that VLR comes under which MSC? That VLR comes under which MSC? All these informations are also stored in HLR. So these informations are part of dynamic information. These are part of dynamic information. Okay. So all these, uh, so this information is necessary to localize a user in a worldwide GSM network. So why all this information should be stored in HLR? Because it is just to localize the user. You have to identify the GSM network should identify where the user so that it can connect and it can provide the service. Okay. So all these user specific information only exist once for each user in a single HLR. Okay, which also supports charging and attending. Okay, so once for all, these user specific data will be stored in the HLR. Okay, so this is about HLR, right? And network and switching subsystem, it also includes another register. It also includes another register, and this register is called as VLR. It also includes another register, and this register is called as VLR. So there is a VLR associated to each MSC. There is a VLR associated to each MSC. So VLR is a dynamic it's a dynamic database. VLR is basically is a dynamic database which stores all important information needed for the MS users, that is mobile station users. It stores all the important information that is required for an mobile station users. Okay, so, so so if a new MS comes into an LA, that is into the location area, the VLR is responsible for it. For example, assume that a new MS is coming to uh, this particular mobile station area. Okay, this particular cell which is controlled by one particular mobile station. Then where then that data where it should go? It should go into the VLR. It should go into the VLR. So it copies all relevant information for this user from the HLR. So, but where it will get the data? From the respective HLR, the data will be transferred to the VLR. Okay. So this hierarchy of VLR and HLR avoids frequent HLR updates. This hierarchy of VLR and HLR ensures that HLR need not be updated always. Okay. So whenever the mobile travels, the VLR will be updated from the HLR, and long distance signaling of user information. Okay, so the point is HLR need not be updated frequently, because whenever the user moves to some other location, his HLR data will be transferred to the VLR, which is in that particular, which is in the MSC of that particular locality. Okay. Mm. Some VLRs can even manage up to 1 million customers. So the database is that huge that it can manage up to 1 million customers. Okay. So this is the brief introduction about network and switching subsystem. So network and switching subsystem contains centers like MSC, mobile service switching center, and it contains two main registers, the home location register and uh, visitor location register. The home location register, it includes static informations like MS ISDN and subscribed features, and the international mobile subscriber identity. Okay. And, and also it includes, and the dynamic features it includes are the current location LA of the mobile station, the mobile subscriber roaming number, the current VLR, and the MSC of that particular mobile device. And the visitor location register is responsible whenever a mobile phone moves from one particular base station to another base station. Okay. So this is basically a dynamic database which stores all information needed for the MS users currently in that location area. If a new MS comes into the location area, then VLR is responsible for it. It copies all the relevant information from the respective HLR. Okay, by maintaining this hierarchy of HLR and VLR, frequent updates of HLR can be avoided. Some of the VLRs also, visitor location register, can also support up to 1 million customers. Okay. So that's it about network and switching subsystem. So the next subsystem that we'll be discussing is operation subsystem. Next is operation subsystem. Okay. So operation subsystem, it contains uh, uh, mainly three things: operation and maintenance center, authentication center, and equipment identity register. So first let us understand what is operation and maintenance center. What is operation and maintenance center? The OMC, that is operation and maintenance center, it monitors and controls all other network entities via the O interface. With the O interface, it monitors and controls all other network entities. So this is the one which controls all the network entities. That is all the network subsystem. It is the network subsystem. All network entities comes in the network subsystem, right? So that is controlled by OMC, Operational and Maintenance Center. Okay. So typical OMC management functions are, some of the OMC management functions are traffic monitoring, like at what rate the communication is happening between mobile station and the base station, generating status report of network entities, okay, creating the status report of network entities, subscriber and security management. It also performs security management tasks, okay, accounting and billing. Okay. So like depending on the how much a user communicates, according to that the bill should be calculated. So that task is also done by operation and maintenance subsystem. Okay. So OMC use a concept called telecommunication management network. OMC use a concept called telecommunication management network, TMN, which is a standard which is standardized by ITUT, International Telecommunication Union. Okay. So this is the task of operation and maintenance subcenter. It is mainly, it controls all the network entities, and also it performs tasks like traffic monitoring, status reporting, and calculating billing and other stuffs. The next center that we have here is authentication center. Authentication center. Okay. The radio interface and mobile stations are are very vulnerable. The radio interface and mobile stations are very vulnerable in that it has many security issues. It has many security issues. So we have a separate AUC, authentication center. We have a separate AUC to protect the user identity and data transmission. To protect the user identity and data transmission. Otherwise, anybody can just tap into an wireless network if they know the frequency at which the communication is happening. And tapping and mobile phone is also not that difficult. So an authentication center is required. So this authentication center is to provide the protection for user identity and data transmission. So that is the primary role of uh, authentication center. So it also contains algorithms for authentication, and also it includes keys for encryption and decryption, and generate the values needed for user authentication in the HLR. Okay. It also stores the values that are needed for user authentication in the HLR. The authentication center may actually be situated in a special protected part of the HLR. Okay. So in HLR also it should be protected, because if you cannot allow everybody to access the authentication center, then the authentication information of the user will be lost. So it will be stored in a special protected area of HLR. So that is about operational and maintenance center. Sorry, authentication center. So the next thing the operational subsystem includes is equipment identity register. So basically, the EIR or Equipment Identity Register is a database of all IMEIs. IMEI in the sense it refers to the mobile device, that is International Mobile Equipment Identity. So it is basically a database of all mobile devices. It stores all device identification details. Okay, it stores all device identification details. So MS are nothing but mobile, and these mobile phones may get stolen, and with a valid SIM, anyone can use the stolen MS. Somebody can take, somebody can steal a mobile phone, that is nothing but mobile station, and they can insert some other SIM and they can use that. Okay, so the EIR, Equipment Identity Register, basically it will have a list of stolen devices, which is also called as blacklisted or lost devices. It will have the Equipment Identity Register will have a list of blacklisted or stolen devices, otherwise it is also called as locked devices. So in theory, once a mobile station is stolen, uh, and in theory, if a mobile user reports that the device has been stolen, the mobile station will become useless. That is, nobody can use that device. But unfortunately, the blacklist of different service providers are not synchronized. Unfortunately, what happens in the sense the blacklist of different mobile providers are not synchronized, and the illegal and the person can illegally use the device in another operator's network. Okay, in another operator's network. Let us say, for example, if you are using Airtel and if you lost your mobile and if you are registering to Airtel that you have lost the mobile, then in Airtel network your device will be blacklisted. That is, nobody can use that device. Okay, but the same device can be used in some other network. Maybe in BSNL somebody can use it because the different service providers were not synchronized. Okay. So the EIR, the Equipment Identity Register, also contains whitelist. Whitelist represents the set of valid IMEIS, that is International Mobile Equipment Identities, or the valid mobile phones. And also it contains a grey list, which contains a list of malfunctioning devices, which contains a list of malfunctioning devices. So this is about the brief introduction to GSM architecture. Okay. So we have discussed GSM architecture under three main subsystems. One is radio subsystem, then network and switching subsystem, then followed by operation subsystem. And inside that we have discussed like several subsystems or several centers or several registers were available. Okay, so let us stop here. Thank you.